Hello everyone. Columns are key structural elements of a building. No matter the building type, columns are indispensable. They support the weight of the beam frame structure and other components. As you can see, at the main entrance of the Great Hall of the People, which symbolizes that the people are the masters of the country, there are 12 towering columns, each 2 meters in diameter and 25 meters tall. The column shafts are made of natural gray marble, and the column bases are carved from granite, giving an impression of solemnity and dignity. Let's begin today's lesson. We will study the plan view of column components. This chapter requires everyone to master tabular annotation method and sectional annotation method for column plan drawings. On this basis, understand and master the column reinforcement detailing method. First, we will learn the tabular annotation method. Column plan drawings graphically convey key information about columns on the column layout plan, using either tabular or sectional annotation methods. The specific procedure for tabular annotation is to select one or several cross-sections from columns with the same identification number and label geometric parameter symbols on them in the column plan drawing. In the column schedule, indicate the column number, the start and end elevations of each column segment, geometric dimensions, the eccentricity of the column cross-sections relative to the axis, and the specific reinforcement values, supplemented with diagrams of various column cross-section shapes and their stirrup types to represent the column plan drawing. The tabular annotation content includes, first, column number. The column number is composed of a type code and a serial number. It shall comply with the provisions in the following table. The column type code is generally taken from the initials of the column name in pinyin. For example, the type code for a frame column is KZ, and for a transfer column is ZHZ, and so on. When numbering, if the total height, cross-section dimensions, and reinforcement of the column are identical, but only the relationship between the cross-section and the axis differs, it may still be assigned the same column number, but the relationship between column cross-sections and grid axes should be indicated on the drawings. Now, let's learn about these types of columns. Frame columns. Frame columns in a frame structure bear the loads transmitted by beams and slabs, and transmit the loads to the foundation. They serve as the primary vertical load-bearing structures. Transfer columns. For example, in structures where the lower floors are commercial spaces and the upper floors are residential with shear walls above a frame structure, transfer members shall be provided at the junction between the shear walls and the lower frame structure. A transfer beam is one commonly used form of such members, and the frame columns connected to the transfer beam are referred to as transfer columns. Core columns. These are generally divided into block-type core columns and frame-type core columns. Block-type core columns refer to columns in the concrete block wall, where steel bars are inserted into the hollow part of the block, and flowing concrete is then poured in to form a reinforced concrete column structure. Beam-supported columns refer to columns that are supported on floor beams. Due to certain reasons, some areas of a building may not have columns at the base levels, but columns are needed at an upper floor. Then columns can only be supported by beams from the floor below. Shear wall supported columns refer to columns that are supported on shear walls, similar to beam-supported columns. When no columns are provided at the base level of a building, but are required at an upper floor, these columns are supported on the shear wall of the floor below. Second, starting and ending elevations of column segments. In the tabular annotation method for column construction drawings, the starting and ending elevations of columns shall be annotated from the column base upward, segmented at points where the cross-section changes or, if the cross-section remains the same, where the reinforcement changes. For frame columns and transfer columns, the base elevation refers to the top surface of the foundation. For core columns, the base elevation is the elevation of the starting position determined by the actual structural requirement of the foundation. For beam-supported columns, the base elevation refers to the top surface of the supporting beam. For shear wall-supported columns, the base elevation refers to the top surface of the supporting wall. Third, column cross-section dimensions. For rectangular column, the cross-section dimensions are denoted as b multiplied by h, where b equals b1 plus b2 and h equals h1 plus h2, with b1 and b2 being the distances from the column centroid to the transverse grid axis, and h1 and h2 being the distances from the centroid to the longitudinal grid axis. Each segment of the column shall be annotated separately. When one side of the cross-section is reduced to coincide with the grid axis or shifts across the grid axis to the opposite side, b1, b2, h1, or h, may the second take a value of 0 or negative. For circular columns, the b multiplied by h column in the table shall be replaced by the diameter prefixed with d. The relationship between the circular column cross-section and the grid lines is also expressed by b1, b2, h1, and h2, with d equals b1 plus b2 equals h1 plus h2. Here, b and h denote the side lengths of a rectangular column cross-section. b1 and b2 represent the distances from the column centroid to the horizontal grid lines, and h1 and h2 represent the distances from the centroid to the vertical grid lines. Fourth, annotation of longitudinal reinforcement for columns. When the diameters of all longitudinal reinforcement are the same, and the number of bars on each side is also the same, they shall be annotated together under the all longitudinal bars column. Otherwise, longitudinal bars shall be annotated separately as corner bars, mid-side bars along the b dimension, and mid-side bars along the h dimension. Fifth, annotation of stirrups. Types of stirrups include the following options, and may be selected and filled in the table as needed. The stirrup grade, diameter, and spacing shall also be annotated. In seismic design, oblique hatching shall be used to distinguish the stirrup spacings between the column end confinement zones and the non-confinement zones. That's all for this lesson. See you next time.